Hello, today we're going to talk about reflections and mirrors. Alright, the first thing we're going to talk about is reflection mirrors. So, there are three different types of what the color stuff is. Opaque means stuff has color. So, opaque means it has color. So, this board, this wall, my shirt, it has some type of color. All right, there's translucent. Translucent means it's kind of like you can see through it, but you can't really tell what's on the other side. A lot of plastic type stuff. I don't have anything here. Here we go. That's my water jug. That's translucent because I can't see all the way through it to the other side. I can put my hand there. I can see through it because I can see my water, but I can't see my hand on the other side. That's translucent. And then there's, so I would say that's just cloudy. And then there's transparent. Transparent, you can see through it. It's like glass. It's see-through. Even though glass does still reflect some of the color that hits it, you can see through it. Like I can look out the window right now and see a tree. All right, so reflection is the color that we see is reflected. So here, that's green because it's reflecting that so I can see it. Here's the example that they had in the thing. So all these colors hit, but the green one is the one that's reflected, and that's what we see. My black watch, it's actually absorbing all of colors. So absorption, all other colors are absorbed. So here, the green is reflected, but it's absorbing everything else. If every color is absorbed, it's black. I have to make sure I want to say that right. So my watch, it's absorbing all the colors that's hitting it. If it reflects every color that hits it, then it'll be white. So if this absorbed every color, I don't know how well this is going to work because it's a red board. But then what we have here would just be white. But if it reflected everyone, or no, if it absorbed everyone, it would be black. If it reflected all of them, it would be white. Transmission is when light goes through a medium. So that's transparent. So when light, such as the light outside, is going through my window right now, that's transmission because my window is transparent, so it goes through, reflects some of the light. All right, plane mirrors. So that's just a flat mirror that you look into. Everything in a plane mirror is reversed, how it looks. It's the same distance from the focal point that you have. So if I'm 2 feet in front of the mirror here, on the other side it should look like it's 2 feet, I think. I should probably take this out because I'm not sure. But it is reversed. Everything inside of it is reversed. But I'm pretty sure that's it. So that's great teaching right there. I'm sort of telling you what I think. But if it's not, I'm sorry. So the next thing we're going to talk about is concave and convex mirrors. So the best example of this is a spoon. If you look on the inside of a spoon, it's a concave mirror. If you look on the back of the spoon, it's convex. So what the convex mirror does is light spreads apart or diverges. So that's why when you look at the back of a spoon, you're spread out. Because the light that's hitting it is actually moving. It's not coming together and converging like they do on concave. They spread out, so it makes everything look larger. So when you look at the back of the spoon, it's actually a convex mirror. So it enlarges what you see because the light's spreading out, and it expands it up. So concave mirrors, this light comes together and converges. When it converges, it actually usually flips the image, and I'm going to show you all the examples of this. So I'm going to hold my thing up here. So you have your center of the curvature, which is just the center of your whole sphere here. All right, we have our, I'm going to call that my COC. That's the center of the whole thing. So if I made this a dotted circle, this right here is just here's the vertex. That's just basically the lens, and this is the focal point. So that's where it all converges to, right there. So I'm not going to draw the whole thing out, but if an object is behind this, what happens with the object? So in this case, I have my vertex, my focal point, which is where all the light will hit on this center line right here. All right, so if I have an image back here, the object behind it will be inverted and shrunk. All right, so that's if the image is way back there behind your center of curvature or the center of the sphere. Right, so if you have an image right here, what happens is it bounces here, bounces down there, and it will be inverted and shrunk. All right, if it is, and the only reason I'm explaining it this way is because that's how it explains it in our thing. There's probably easier ways to explain it, but I'm trying to stick with it as close as they do. All right, so your center, you have your image right there. It's the same size. So if I had a tree here, I would just have a tree, same size, right there. And it's just inverted. All right, and the very last one is if I had, and our last one, if I had an image right here, all right, so say this is a tree, which is what they use. All right, my tree would actually be back here, inverted, and much larger than my original tree. So there's three different kinds. So if the image is back here, it's going to be, when it's reflected, the object will be inverted and shrunk. If it's right at the center of the curvature, it's going to be the same size, just inverted. And if it's between the center of the curvature and the focal point, it'll be inverted and larger. So those are just the three different ones that you need to know. All right, this has been Reflection and Mirrors. I hope this helped. Good luck.